The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Hey Ben, last week we made the mechanism for the autostand.
Yeah, we figured that we could have a metal wire stand and push it forward and back with a cable. We used a guitar string, and that cable is actuated by a servo, and it seemed to work out pretty well. We also created a servo library for the ATtiny.
So what's our plan this week?
This week I want to find a capacitive touch sensor library for the ATtiny so we can make a new trigger with a little metal plate in it, so when your finger touches it, not pulls it, just touches it, that's when the stand retracts or extends. Yeah, Atmel has something called Qtouch that we might be able to use. So I think we should look into that. And also I want to build the mechanism, or just a prototype of the mechanism, into our prototype gun as well.
Okay.
So by the end of this episode, I want our glue gun to be like,
That sounds cool.
all right, let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
All right, so this is where the magnet goes. The magnet is a 1/4 inch wide. I'm going to do this first. I'm actually going to do a better job of capturing the magnet in this case. So let's take this sketch geometry. Let's just go out and up. We don't need to attach any wires to the magnet, so it can be completely enclosed, which is good, which means it can't move, hopefully, unless it does. Oh no, I parametrically changed it. It's mad at me. Okay, so the magnet is a 1/4 inch wide, which means half of it is, 1/8 inch, just like everything else. So that number works out well. I'm gonna go a little bit further than that, just to be sure. Now let's back this up. We're going to want to fillet these to make it a round enclosure for the magnet. All right, so we're gonna go pretty much all the way. Yep, 1/3, which is also the depth, and is also the radius. Okay, cool. So what we'll do is we'll glue or stick a piece of metal here, and hopefully we can do the capacitive touching through this 2mm piece here. We should be able to. All right, so I just have to do the same thing vertically upward, and then I can print the two pieces. Okay, I'm going to build this mock-up that we did in the previous episode onto the existing glue gun mech. It's just a faster way to test it before we actually do a bunch of redesign of the case in the computer. I flipped the barrel around so the hot end, or the heater block I should say, is at the top, which gives us more room for our stand. Now I had to put a spacer in this because the stand, has this extremity here. So it has to be clear of the heater barrel. I'm going to hot glue together the hot glue gun. So meta, hashtag meta. Okay. Looks like everything is pretty much in place. And it's not perfect, but it's just, enough to give us a proof of concept before we redesign the top half of the glue gun. One potential problem I thought we might come across is after I flip this around, I hope these wires are actually long enough to reach the sensors, otherwise I might have to extend them. So behind me, Felix is working on researching the Qtouch library, which is a proprietary library for Atmel microcontrollers. We were thinking we might give that a try for the touch sensor. And I did print the holo trigger here. So we got the magnet in place, and then we basically put the sensor piece of metal here, the wire coming out the back, and then we glue it together and then put in the spring. So I'm just gonna get this tidied up, make sure the wires all reach, and then hopefully we can get the new library installed. I mean, the library we worked on in the previous episode did work, but it was a little hackish. It doesn't use any specialized hardware. It basically just uses standard I/O pins. If there is a specialized capacitive touch sensor built into these ATtinys, I want to use it. Hey, check this out. The magnet has to be the right polarity or it doesn't work. Let's see. it doesn't work. The Hall effect sensor, or at least this particular Hall effect sensor, senses north and south magnetic fields. So if we hit it on this side with the wrong field, it's not going to do anything. But if you flip the magnet around, then it reacts. See the gearing going? So I have to make sure I assemble the magnet in the right orientation. I guess I could just mark it with a black marker. That would work. How do you plead, Lord Baelish? I think I'll put a little piece of metal here along with the wire so we can use it as the touch sensor. I can unplug the gun now since I know the magnet's correct orientation.
So, Ben, I am anxious to see this new library you found.
Yeah, we had trouble finding the official libraries that supported the microcontroller we had chosen. So I just did a random Google search for, what was it? ATtinyTouch library. And there's a couple results on GitHub.
All right.
It's kind of sad that we can find it on GitHub faster than we can on the official documentation. Yeah, so this user, CPLD CPU, what do you think? That's complex programmable logic device CPU?
Yeah.
Well, anyway, that's her username. He has something called Tiny Touch Button. He or she, it could be either. Yeah, so they have a library called Tiny Touch, and he's got an entire Atmel solution file here, so we could load this up and check it out.
Oh, cool.
And it has configurations for, yeah, all the ATtinys, including the ATtiny 10, which is much wimpier than the chip we're using for our glue gun.
Awesome.
Yeah.
See, there's a schematic there. That's
Oh yeah. Look
cool.
how this is great. This
Well
is
done.
great.
Bravo.
So, Mr. CPLD, we're gonna definitely use your code for inspiration. Thanks. Yeah. So I had to add a few things in here. So the frequency, 8 megahertz. So this is pretty standard. Then he's got his example actually runs NeoPixels too. So check this out. He wrote some machine language to manually do the timing for the NeoPixels.
That's cool.
Because the timing is so accurate, you have to, you have to use machine language. So you know exactly how many cycles are being executed. Yeah, so anyway, you start the function, tiny touch init, and then I think you have to set the pins. I'm not exactly sure where that's defined. It might be in the H file. But anyway, then you have what state, push or release or press. So it can detect if you're holding on it, basically.
Okay.
So let's plug it in. Yeah, so we have a sense plate with 50K going to it.
Okay.
I hooked up two 25K just so it would hold it a little better. Yeah, so it's got like demo lights going, and then when you touch it, they'll go all white. And see how my finger's not even remotely close?
Oh yeah, that's really good.
Yeah, let's see if we can find like a piece of plastic like in the bin, like about 2 millimeters thick.
Sure. What do you think?
It's almost like too sensitive.
How much space does this take up in the program memory and everything?
That's a good question. Well, it fits on an ATtiny 10. Oh, 878 bytes and 16 bytes of RAM. And then our chip, we were using, 1152 bytes out of 2K, so yeah, it should fit. I mean, it's gonna be close. Of course, we could probably remove parts of the library that we don't need. I mean, all we really have to do is take the important stuff. Right here, this is the money shot, the Tiny Touch ADC.
Bam.
Which means it uses the ADC mux. I don't know if you knew this, but the multiplexer on the ADC on these AVR chips,
Okay.
it can only sense one at a time.
Oh.
So it's kind of like a selector, like, okay, I want to sense that ADC. Now I want to sense that one.
Yeah.
So I guess, I mean, you can only sense one at a time anyway, because only one thing can happen at a time on this chip. But yeah, you have to actually set the multiplexer to which one you want to sense. In our case, like 0 to 7, and then you take your reading. So we'd have to make sure this thing takes turns with the ADC that's sensing the Hall effect sensor trigger. But it should be all right, because I mean, the loop's already pretty fast. So what is it? We have a total of, we'd have an ADC for the trigger, an ADC for the touch sensor, then we have an interrupt driving the servo, and then we have the other system timer driving the PWM. So we're using up quite a bit of this chip's capability.
That's pretty awesome.
Yeah, it's kind of fun to, I mean, the real trick is getting all those things to work in harmony. Because sometimes, like if you're using something like Arduino, like the millisecond timer, I mean, you don't know that it's happening, but Arduino is using up timers or a timer to run the millisecond timer, like for milliseconds and delays. I mean, you don't know that's happening. So if you go in and you try to manually set up a timer within the code, you could, but if you're colliding with something that it's doing, then it won't work. But by reading the data sheets, we can make sure that we're not colliding with anything. Like this thing only has a single timer, but it's 16-bit. All right, well, I think this is probably has a good shot of working. So what I'm gonna do is I'm gonna translate the code over into our code, basically.
Yeah. Will you send me a link to that GitHub?
Sure.
That repository?
Yeah. So what I'll do is I'll probably just I'll program this onto our other dev chip, and then I'll put it in make sure it works on that, and then put it into the gun. So the main thing I'd be worried about this affecting is the other ADC. Oh wait, no, it wouldn't affect the interrupts, because when you ask for a ADC measurement, it will calculate it, and then you basically wait until it gives you the calculation complete flag. So I don't think an interrupt will affect that.
Okay.
Although it could.
So you're saying that
That's why ADC is so slow, because you have to wait for it.
Okay.
Yeah, there's probably a part here. Okay, Tiny Touch ADC, pre-charge. Oh, there's a delay of 32 microseconds. Got some defines, we could remove those. Start conversion, oh, right there. See where it says while ADC SRA. So basically it's waiting for the conversion complete flag to be set, and then it continues on.
Can an interrupt interfere with that?
Well, of course it could. But the thing is, that conversion's happening in the background anyway, so that conversion will continue even if an interrupt is changing the main code.
I follow.
I mean, that should be how it works, because it's the hardware doing the conversion, not the code.
Right.
But the code sits there and waits for the hardware. I mean, I guess you could have an interrupt where you just jump out of there, and then the interrupt is triggered once the flag is set. I mean, there's probably an interrupt that's like ADC conversion complete interrupt trigger. All right, well, I'm gonna translate this over.
Cool.
I've been going through this library and changing everything that will make it compatible with the AT-Tiny. The biggest thing that I saw was I had to change all the ports. The AT-Tiny 10, everything's port B, but on our AT-Tiny 20, all of the ADCs are on port A, not port B, so I did a find replace with all the port definitions. I did notice this library does use 2 pins, like 2 analog pins. It uses one that's disconnected as a reference, and then it compares the sense pin to that. So we can just leave one disconnected. That's not a big deal. I think we'll still have enough I/O. And there's a mosquito in here for some reason. Something else I had to change was the timer mode, because remember, this still has to be compatible with the ADC that we're using for the analog trigger with the Hall effect sensor. So I changed the prescaler to 16 instead of 64, which this library had. Then I also set it to write justify the data. So the AT-Tiny, the little one that the example is written for, only had an 8-bit ADC, but this AT-20 has a 10-bit ADC, which means there are high and low registers. Oh yeah, here we go. Yeah, see, we have ADC low and ADC high. So it's 2 bytes put together to make a larger number. So it's either defined like this is write justify, so we go from 0 to 7 in that byte, and then 8 to 9 in that byte. Or it's left justified, which is what the library was using, where it puts most of it on the left and then just chops off the lower 2. Now again, that library was expecting 0 to 255, so our library is going to use 0 to 1024, which will give a little bit more granularity. So we had to change that, and I think that was about it. Yes. I'm still dialing in the sensitivity because that's going to be different now that we have more resolution. Okay, so here's the trigger. It's got a little metal plate, and that metal plate is going to set it off. Now, if you touch it, it's too sensitive, but again, it's going to be enclosed here like that. I'm going to put the bolt in place because, you know, we have to assume whatever metal's around it is around it. So the magnet, the spring, everything could possibly affect it. So here comes my skin. Now, we also could trigger it from the side. We have to take that into account as well, because obviously, you know, if you're holding this, you know, we want this to trigger it, not just that. Because if you have to bring your finger too far away from it to retract the stand, that's kind of inconvenient. Because you'd be like this, right? I guess that kind of works. It looks like a fancy person holding a teacup. I'm a fancy person holding a teacup, right? Yeah, see, my finger is triggering it from basically any side. I guess we could adjust the sensitivity some more. Well, the good news is this library works on the AT-20, so before I dial in the sensitivity too much, I think I'm going to translate this library over and put it in my main project and make sure it plays nice with all the other things that are going on, and then I'll dial in the settings. Okay, I've been experimenting with merging the libraries. I have run across a couple issues. When I took the touch library and put it over into our existing glue gun library, it sort of works, but it has some problems. I'm trying to figure out if it's because of the way the ADC is being sampled or if it's something else. Hey, I think I found the problem. It is the prescaler. Okay, so the prescaler is something that takes the system frequency, such as 8 megahertz in this case, and divides it by a certain amount. Like that's how you drive the interrupts, that's how you drive the servos and all of that. So anyway, I was using a prescaler of 16, but turns out a prescaler of 64 actually works. Okay, so what you do is you set bits. Actually, let me go back over here. See AD prescaler 210, so it's 3 bits, and here's a table of what those bits do, right? So it's going to take the system frequency and divide it by 16, 32, 64 if you set this bit pattern. So what you can do in the code is you can have the control register, you can OR in the top bit, which enables ADC enable, and then you add whatever prescaler bits you want. You could also do it like this. You could do AD register A equals, you can type it out in binary, 1, 1, 2, 3, 0, 1, 1, 0. Okay, yeah, that would be the same thing, I think. You know, whatever works for you, or you can use the defines. You can also use this macro. I don't really like it that much, but you can go BV and then just type in the item in parentheses and it'll do the bit shifting for you. Yeah, so now I have all the ADCs running and it's working. So I guess, you know, I'm not entirely sure about the correlation between the ADC prescaler and the sample rate. It's like these bits determine the division factor between the system clock and the input clock to the ADC. Okay, so 16 didn't work, but 32 did. So really, we're running it slower, and slower is working better. Yeah, the original code just did a 16 division. Oh, wait a minute. Oh, no. Oh, look at this. It did do. See, I commented it out. Let me find the original code. Yeah, here we go. So my code, I was using a prescaler of 16, and the touch library was using a prescaler of 64. Yeah, so by changing the timing of the ADC, it was causing the touch functions not to work. So I need to make sure my ADC functions, specifically the temperature sensor and the trigger sensor, are running at the same frequency as the touch library, and then they'll all work together. Yeah. I mean, I won't really know that until I hook the motor back up, but it should work. One thing I did change, though, was I went into the touch library and I adjusted the data like this. So my libraries are using 10-bit sampling, but this library is using 10-bit sampling, but it's left justified, and then they're only using the top 8 bits. So I have to take a 16-bit sample and then bit shift it 2 to the right to simulate what the touch library was doing. But now it seems to be working. Yeah, so I'm going to plug the other stuff back in and make sure the analog trigger control still works. All right, I think I have everything that I need. So I'm going to put the trigger back together with some Scotch tape, which will be good enough for now. I've got a pair of 100K resistors here in parallel, which cuts the resistance in half down to 50K, which is the value that we want. I want this wire to be as short as possible, but also not travel too far. Here's a toothpick for now. There we go. It's kind of hard to get at, so I'm going to do the cheap trick of just heating up the wire to cause plastic to contract. Not the best way, but it'll work. There we go. All right, I'm going to start plugging in the wires. So here's the temperature sensor, servo. Okay, motor controller. I guess I'm going to snake that over. And finally, the triac. All right, now I just have to put the case together and then modify the code. So instead of blinking an LED when you touch the trigger, it changes the servo to its 2 different states to retract and extend the stand. So yeah, let's say you've got your glue gun sitting here on the table, right? And you're like, oh, it's sitting on the table. Now I've picked it up and I want to use it. So you have to exercise good trigger control, but then when you're ready, yeah, now you can just stick the nozzle in there. I've noticed actually pulling on the trigger a little ways and turning on the motor actually resets it. So we have to put a little bit more logic in there, but you know, whatever. Let's try extruding. Yay, that part still works. Fine lines, thick lines, little glue or a lot of glue, as much glue as you want. It's the super glue gun. Are you tired of this happening to you? No more with the super automatic stand glue gun. I don't even have to explain why it's so cool. But anyway, yeah, the capacitance touch, you know, it was important to get it right for me because, I don't know, I mean, if you made it so like you just had to pull on this a little bit, it would be a little flaky. Yeah, so I wanted like touching the trigger and pulling the trigger to be, I had to be careful, it's gonna actually extrude glue when I pull the trigger. I wanted those to be 2 separate actions. And by using capacitive touch, it seems like it does a pretty good job. I mean, we need to dial it in, and obviously this is just the rough prototype, but everything is there. Ew. See, this is the trick, like you can just keep going. You don't have to like, squeeze your hand repeatedly. Well, that's all the time we have for today.
If there are any common tools that you think could be improved, let us know on the Element 14 community at element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. Stick around. Lord Baelish. We have a table filled with oscilloscopes.
What are oscilloscopes and why are they here?
We're going to talk about the differences between the scopes, what they can do, and then put them all through some demonstrations.
Hey, check out this awesome feature. That was a great discovery. I think it's nice and cuddly.
It loaded already. That's pretty awesome.
Freaking cool.
Oh, you and your quantum entanglement.
It's off the charts.
Wow, data. Hey, it's the NTSC color burst frequency. It should do nothing.